point of this talk is to really wear two hats. One is a criminal and one is a white hat. And there's the proliferation of containers, microservices, with SaaS products that are out there. And nothing would be awesome in terms of an exploit from a criminal standpoint in terms of going into Microsoft 365, Office 365, or Salesforce, or Uber. Will cover Uber in this case. Anything that is relying on massive IT environments. And as we all know, the traditional IT environment has changed. So this talk is called Attack Tree Vignettes. Vignette is just simply a storyboard. And attack trees is a type of model that you use in application threat modeling to be able to have a logical attack flow, almost like a kill chain, where you basically see the branches of your attack based upon your threat motive. So for those of you that don't know, I am the co-author of a risk-based threat modeling methodology called PASTA. Me and my co-author, who's Italian, and that's maybe why we call it PASTA. The acronym stands for Process for Attack Simulation and Threat Analysis. We wanted to come up with a threat modeling methodology to be able to think like criminals and to be able to justify the viability of different attack patterns against an application, against anything, against an organization, against an infrastructure. And so that was the intent. Today, we're not going to focus on the full range of the threat modeling methodology of PASTA, but you can Google it, and there's a lot of information out there on that methodology. It is a risk-centric approach, which simply means why boil the ocean, why cover all the security bases of imperfections in your application environment? Focus on the things that are most probable in terms of attack patterns based upon credible threat intelligence, precedents of attack, and things that are most impactful as of the application. So we'll look at today, we'll talk a little bit about the importance of, and we all know this as hackers, the importance of fingerprinting your target, of understanding your target. What are the use cases of your application that you are trying to get into? In this case, we're trying to get into multi-tenant, containerized cloud environments. And then we'll look at the attack modeling aspect of how do we basically envision different types of attacks. Now, if you've done some threat modeling, you probably think about application threat modeling. But attackers don't think just in application terms, they think in also process terms, or human weaknesses, or possible misconfigurations because of imperfections in DevOps. So this is more of part of this will be trying to understand how are DevOps operations evolving today. We know that it's fairly immature in many respects in different organizations. So as criminals, they can take advantage of those inconsistencies in processes, and we'll see what specific technical exploits they could do against Linux-based containers or even orchestration solutions like Kubernetes. All right, so just really quickly, the significance of this talk, this is the outline of the talk. We'll get into, I'm going to move quickly because this is 40 minutes to cover a lot of information, but this is the outline. We're going to talk about the importance. We'll go into threat motives and attack vignettes. Why would someone want to go into the cloud? My question really is, why wouldn't someone not want to go into a SaaS environment and have persistence? Right? If you're a criminal, you want to be able to really own an environment and own a multi-tenant environment. Having persistence in that environment is awesome. We'll have a storyboard of an example on a SaaS solution, a business-to-consumer application that's pretty prevalent in the States. It's called Uber. Anyone here not heard of Uber? Okay. And then we'll talk about some countermeasures. So just a little bit about me. As I was introduced, I run the Atlanta chapter. I'm also the CEO for a consulting firm called Versprite out of Atlanta, and I wrote this book last year with my co-author, Marco Morana, who's also involved with OWASP out of the UK. He works for a major financial institution. If you have questions on this, feel free to contact me. All right, significance. So containerization has grown. And if you think about the benefits of containerization, it's really easy to see the timeline of events since the late 70s. You're having, right now there's a rapid adoption. In fact, some of Docker containers, as an example, is one of the most highly adopted forms of technology on the planet today, bar none. So there's a lot of companies of different segments, retail, banking, financial, higher education, government, that are looking to explore containerization. So from a criminal standpoint, this is awesome. We want more people to adopt, containers and containerization, and we want people to maybe, in this open source world, to be able to download different public registries, because they want to quickly get in the game of instantiating a containerized environment, and quickly they want to be able to maybe download a Docker container for their Redis cache server or their Nginx image within their containerized environment. So the point here is that you have companies like Google and Amazon and Salesforce.com, multiple Netflix. The efficiencies of containers in the cloud are IT efficiency, operational efficiency, redundancy, and sustainability of services. So there's the business case. And as kind of criminals, you want to understand where the adoption is. And a lot of the adoption, thankfully to open source forums, is basically being highly marketed. And again, that's great open source intelligence if you're in the criminal sector. So these are some of the labels or name brands that are out there. CoreOS, and Rocket. Rocket has come out with their kind of Rocket containers. They have the 4 pillars of service model, where they actually are trying to go beyond what Docker is doing and factor in more security into their containers. But their goal was the same as any other goal in the microservice business, and that is to basically facilitate decoupling of applications. And as you all already know, most applications today that are traditional legacy are either on-prem or hosted, managed hosting, or co-location, and they follow usually a 3 to 4 tier architectural model. With this model, you can basically decouple your monolithic web applications, web services, backend databases into container farms that are independent of one another. Now, in terms of the use cases of running containers, there's really kind of 4 major ones. And as you can, from a system administration standpoint, there's a create, there's a destroy, there's a maintenance of what goes into your containers through for example, your Docker manifests. Manifests, really provide the metadata so that a lot of your applications can be software governed. So you're now having with DevOps the ability to script out what is your application stack, what is your server stack, your platform stack, what is your user model, all within these different manifests. And we'll talk about how to exploit these manifests in different ways. But as we look here, one of the things that is one attack pattern. Let's say that you want, as a criminal syndicate, you want to be able to, or a competitive, you're a corporation that, and we'll talk about this as an example with Uber and another competitive company called Lyft. Let's say you want to, create a DDoS scenario, an application DDoS scenario, either because your motive is related to reputational impact. You want to be able to destroy the reputation of a company based upon their availability. In certain services and business, things like Uber, where you're waiting for a car to happen, time is of the essence. And in other services where, like marketing, if there's a marketing SaaS platform, you maybe have some time, it doesn't work, you can come back 2-3 hours later. So your threat motive has to match what is going to be of impact to the actual target entity. As the landscape of SaaS solutions grow and DevOps begins to evolve more, the traditional form of system administration and doing software builds is changing. We're living in a highly more agile environment. How many places today out there are you guys still doing traditional waterfall? Is it anyone not doing agile, where you're looking for greater iteration, doing sprints, of your applications, and everything is very quickly executed. And this is where the big push for efficiency is being driven. So in terms of attacking these types of organizations that are operating this way, different attack patterns that are both logical and physical include the targeting of DevOps team members. And because of the open sourceness of different online forums, you can quickly profile who's working in DevOps at your target bank, target government entity, target business to consumer entity. And so you can quickly find out who's doing what and befriend them as a social engineering artist. You could also look at public repos to see what's been published by a target entity and see how their application stack looks like, what flavors of micro frameworks they might be using, like Flask or Bubble or anything like that. So attacking DevOps team members, trying to also rely on human inconsistencies for how they misconfigure namespaces or control groups. Namespaces are basically what provides isolation in Linux containers and in Docker containerization. And the control groups provide the allocation of resources for memory and file system and input-output I/O. So things are moving really fast, so as a hacker, you want to be able to say, how can I get in and gain persistence? Well, one of these ways, and we'll talk about this a lot, is the Trojan horse of implementing malicious or tainted repos. Not the repo, the entire repo, but images within those repos where you're downloading different client-side container clients, like Docker client, or actual Docker images. So, the model is changing in terms of how attackers are going to be attacking these different providers. And the goal here, the end goal, is persistence. Just like the end goal traditionally might be to have, a persistent presence, through a botnet or an exploit kit on a mobile phone, a mobile exploit kit. You want persistence so that your persistent, malicious, tainted image can basically communicate back to a command and control center and be polymorphic and change. So this is very interesting in terms of a criminal and attacker model, and we're going to talk about certain attack trees to kind of exemplify this. So here's an example of what I'm talking about. I just updated this slide yesterday, and I'm sorry you can't see this too well in the back, but basically MesoCloud is part of Mesosphere, and there is Mesosphere is kind of like an abstraction layer for orchestration of containers. And this is one of several different forums that basically talk about, people having problems with their containers, the configuration and whatnot. And here we see the exemplification of how some Docker images are outdated and misconfigured. And this is an actual user that's actually complaining about it. And then you have someone from the MesoCloud team that is basically saying that things related to different types of root user privilege misconfigurations, he's acknowledging that is a problem, and Docker had the same issue. Docker had the same issue with some of their 1.x releases where their privilege model, their users model, was just too elevated, and in some cases by default you still have a set UID ID where it equals 0 and you're running all your Docker containers as root. But here, this is an example where these forums, if I'm a criminal, I'm doing a lot of, of combing through, doing open source intelligence gathering of who's using what technologies, and we'll get to some, we'll get to an example where we profile a DevOps engineer for a company that is in the United States called Uber. So let's talk about threat motives and some attacker vignettes. So in threat modeling, there is this notion of use cases. If there is a function, there's a possible dysfunction, right? We can all agree with that. So with containers use cases, we'll look at some of the things that exist in terms of functionality and what sort of things can be abused. So decoupling of services. When you decouple services, they're still run as a a certain UID ID that's on the host. And oftentimes, DevOps engineers aren't really too cognizant or aware of what is the actor that is actually running these services. And so in terms of an abuse case, you have opportunities for implicit trust abuse cases, where you have things like privilege escalations because of misconfigurations. Process isolation, resource dependency, web-enabled APIs, these are all functional use cases. Like, for example, the web-enabled APIs. There is these Docker repos that you can basically interface with from your Docker client in order to basically send you configuration details of how your Docker farm should behave in terms of, so if you have a Docker farm that has an Nginx web server or a Redis cache server or a Memcache server, and you want to be able to now implement new changes to those images on the fly, then there's a web API for that. And as web application security professionals, when there's a web API, what do? We fuss parameters, right? So you basically, there's some of the abuse cases here in terms of attack patterns are really synonymous to what we've been doing as attackers for a long time. Container marketplaces, in my opinion, is still one of the more, I think, attractive attack patterns because as a criminal, you can foster repudiation. You can basically embed malicious commands in a container image, and you could even do almost like malvertising or promotions of your Docker image or your Rocket image that you have on a particular repo. So let's look at some of the components that you would attack as part of a threat model for containers. Let's look at the Docker run namespace. So the whole point there is to achieve isolation, and you have control groups that really control access to the file system, access to memory, access to other different resources. The configuration is largely, like I said before, Docker hasn't done a lot of things out of the gate, unlike Rocket. And I'm trying to compare the two, but Rocket, one of their key goals has been to foster more security from the very beginning in terms of their containers. But the prevalence of misconfiguration of isolation is extremely high. Docker daemon runs as root. It's on /host on the host system. It's vulnerable to multiple different types of other inputs and during load and pull actions. And so, the Docker daemon, again, runs as root and can be attacked in order so that you can do privilege escalation. When you basically do, like, make the process a bend and you force it to have an exception, you can try to do from another container that's malicious, you can try to do a injection-based attack into that memory process where it abended from. There's a research paper from Cornell and North Carolina and also European University where it talks about side channel attacks and doing just that from a neighboring container. So if you're trying to launch some of these attacks, the great thing about these cloud solutions is that you can go in as a legitimate tenant and consume some of the SaaS or platform as a service offerings, knowing that there's other tenants that are also in the organization. So basically becomes your hackerspace, right? So you basically introduce your own malicious container that is being governed by an orchestration platform like Kubernetes, pods, or through Docker clients. So you want to be able to introduce malicious containers to interact with some of the other containers. But these side channel attacks do some of these things like exploiting the different PIDs that are running as root. The REST API can be exposed, and this I already talked about being able to fuzz different parameters when you're interfacing over the web. And in some cases, TLS is not configured by default. And we'll get to some examples on that. So I invented this term, just called dishing, just to be cute. I'm not really trying to, be pioneering or anything. But there's phishing, there's smishing, there's vishing, and I thought, well, what the hell? let's call this dishing. So having a tainted container introduced into a repo where it basically has all of your malicious intents. Now, how would you do this? You would obviously have to look at a pre-constructed container that is in a public repo. There's public repos for different, organizations, for Amazon, for Netflix, for anybody that's in the kind of the DevOps and containerized microservice business in terms of their IT. And so the goal here is to deconstruct the functional use cases of a container, understand its Docker file, and then be able to create your own and introduce it as a kind of like a blind, attack pattern where you're hoping for consumption from engineers that are just getting into this, and they want to be able to instantiate, a new Postgres DB. So the point is, this is actually happening already, and I think there's a lot of, prevalence and warnings by these manufacturers to saying, hey, be careful what you buy. And if you think about, well, hey, Tony, what about certs? These Docker images are being signed and whatnot. Well, there's obviously, there's ways where you can basically impersonate or taint a CA server, and we'll go through a data flow diagram in a second on that. Historical container weaknesses that have happened, and I've mentioned this briefly, is that historically Linux containers adopted a model container where it really focused more on isolation and less on security. Now, in Docker, basically inheriting Linux containers as part of its solution or technology set, basically was very susceptible to tenant breakout. And there's nothing more gangster in cloud hacking than tenant breakout, because you want to be able to escape out of your isolated container and go and interact with other containers so that you could basically maybe do privilege escalation or side channel attacks. Adding users to Docker groups. So when you start out, again, you have a root user privilege model. It's highly elevated, obviously, but you add users, you can add users. And some of the weaknesses that have been found is that many users were added, but with root privileges. With elevated privileges, and elevated privileges to run, simple cron tasks, that might be doing, parsing routines, in your application environment, or they might be doing some, database insertion routines, into your relational database or whatnot. So, these sort of, routines where if you basically look at, a CRUD model, create, read, update, delete. You should, best practice, you should see what sort of things require update, delete, and the actions from an actor on your application environment that just need read should just be deprecated user models. But the one thing that we can rely on for, in IT, history is misconfiguration. We're going to have misconfiguration in on-prem environments or traditional hosting environments is something that is a little bit more admissible compared to cloud-based environments. If you're going to screw up in a multi-tenant environment on a misconfiguration, the impact is so much more detrimental. Now, these are some old statistics as of January of this year, but I'm still sharing with you. So the notion of dishing by introducing kind of a tainted image, look at some of these information here where you have the Docker Hub overall has 15,000 pre-built containers, 500 million downloads. Again, Docker is one of the most highly consumed technology components today. 30% of containers have vulnerabilities and no security inspection by Docker. Now that's recently changing. As of like 2-3 months ago, Docker has introduced a service model where they're doing some level of dynamic inspection into their images. But again, it's dynamic analysis, and we all know that with dynamic analysis going through an automated process, you're definitely not going to catch everything. So you can still basically use this as a platform for kind of Trojan horses. Official images from Docker, there's roughly 100 official images that have, they're known to be forwarded from Docker, but greater than 90% of official images have vulnerabilities. And now they do have some level of security inspection, but before that was not the case. Sorry for the non-conforming AppSecEU slide, but I just added this. And I just kind of wanted to show, like, here's an example. If again you're a DevOps engineer, and look at all these different types of clients for different types of, different types of frameworks and languages that you want as a DevOps engineer. And you're thinking, well, okay, great. I'm using Go. I want a Go client for my, Docker management. And so you have all of these different clients, but you have on this page, you basically have, this is a public repo. You don't know where, who basically compiled the client, or who basically, is introducing this, who's managing it. And a lot of the, like Apache and Docker, they're both saying, hey, it's great to have open source, but I think there's going to be an increase in these types of Trojan-related horses where you can basically insert tainted images or compile clients into, these public forums. Okay, I got to hustle because I only have 15 minutes left, but I wanted to show this slide here. So this is an attack surface for kind of a mature, containerized infrastructure environment. And so in this particular situation, you manage different technologies with different SaaS solutions. In GitHub, you might manage your Docker code base, your Docker file. You might manage it there as a DevOps engineer. If you're using Kubernetes, you have your etc daemons that are serving as to govern the overall framework of your Kubernetes pods. And this is basically the keys to the kingdom in here, because the etc daemons govern the shared secrets that you have for your Kubernetes pods. So there is there's a cloud control file with Kubernetes that oftentimes many DevOps engineers are putting their shared secrets into these files, and they're completely unencrypted. But if you're thinking about like an attack model, as we're looking at the attack surface, Docker file tainting is awesome, and being able to contaminate these types of configuration files, which really govern how your Docker image is going to behave and be configured from a security standpoint, or lack thereof, is a great attack pattern. So you have that. You have obviously the social engineering of your DevOps. We'll go into that in a little bit, as that we would target make an example of Uber in a good way, not in a bad way. Well, kind of in a bad way, but then you have the repo. I can barely see anything on here. So then you have the repo, where basically you're trying to introduce your tainted images into a public repo. And there's tons of public repos out there. And some of them are not even from the actual manufacturer of the container manufacturer, like Docker or Mesosphere or CoreOS. There's other kind of commingled different containers that are open source for the benefit of a wider group. So the key targets here, the etc daemon and the Kubernetes environment is definitely where you have the keys to the kingdom, and then you have things like API servers, which again, this goes back to just traditional web application fuzzing. You have, when you're controlling your containerized environments, and you're basically trying to basically issue commands like run, or issue some parameters for configuration. This all happening over HTTP. And in certain instances, a lot of DevOps environments are actually not running this under TLS. You have to configure TLS verify under different types of containerized models. So Zookeeper has been known to have exploit memory misallocations, catching unhandling exceptions, and other types of bugs. How would you actually attack something like that with these types of vulnerabilities? And it basically goes to being a tenant within a multi-tenant environment, where you might be at the application level of a container that's residing on a platform stack, a containerized platform. And so you want to be able to realize that, okay, if I'm an application one, and I'm basically an adversarial application, and I see there's an application two that is my target victim application, I want to be able to realize what sort of underlying platform services we're both depending on, so that I could see what exploitation I can do from the application layer down to the OS layer. So let's talk. I have 10 minutes left, but this is Uber. Uber's a great app, it's very beneficial, but they've been doing a lot of socialization of that. Hey, we're using microservices, we're using containers, and this is the, you know, we're using Debian packages as well. You know, you go online and you basically, you know, I skipped over this one, but this is basically looking at a threat model of why you would attack Uber. I'm not advocating this, by the way, as my legal disclaimer, but I'm just saying that if you were, you know, you will understand that, you know, they want segment growth, they want to grow their services, they have different lines of service, and if you're a competitor and you want to defame them or you want to reduce their credibility for availability, that's definitely a good take. You want to steal their drivers. You want to be able to target then their database repos that have driver information and PII. But going back to this, you know, a lot of companies are advertising, you know, in different types of open source initiatives like OpenStack. You know, there's a lot of companies that are part of OpenStack, and OpenStack is kind of, yeah, a dying movement in my opinion. But, you know, especially in the United States, it's a little bit, you know, more outdated compared to some of the evolving, you know, open DevOps efforts. But a lot of places are advertising this is what we're using in terms of our stack. But, you know, some of your own open source intelligence gathering using tools like, you know, Built With, which is one of my favorite sites, you can basically put in a containerized, what I know a containerized environment because they just told me that they're using microservices. And you know, they're advertising it, so I know that they're using containers. So great, I picked my target. Now I want to see what their technology profile is and what types of applications they might be virtualizing at the application layer. So I'll use something like Built With to basically do the enumeration for me. And I'll also use, you know, look at job boards as a hacker, because if you're hiring for a certain type of technology, chances are that you're developing for your overall platform. So here's a data flow diagram where basically you have, you know, you have basically a Uber-related Docker hub, and then you have a public, or here's a trusted registry for Uber. This one runs in AWS. They have a Docker file here. They have, on this one, this is their own private one for Uber. And they also manage that through their Docker file through Git. This is all stuff that you can easily derive just by connecting the pieces of their Git repo, their branches there, also what they have in terms of the OSINT stuff that you can get from like Built With, and also some of the things that they're just, you know, naturally confessing to. But, you know, what I want as an attacker is I want to be able to get my image into their containerized environment, so that I can maybe do a breakout or I can do a side channel attack. So we'll skip over this. Application decomposition is, from a black box perspective, is how does my application container actually interoperate with some of their existing applications that are containerized as well. But I wanted to kind of provide an attack scenario where Lyft, and this was actually in the news, so this is snippets from the news where, you know, Uber, there was some like blaming of the Lyft CEO that he was behind a targeted attack to Uber to create some downtime, and this got, you know, a lot of good attention, and, you know, so this, and whether credible or not, the point of the matter is that there's a threat motive for, especially when you're competing head to head and there's no one else in the market, there could be another threat motive related to privacy. You have tons of personal information, or maybe if there is a new use case where you can basically affect the Uber client, and the Uber client gets new functional use cases from a container that's running in the Uber container model, then basically you can, you know, indirectly transpose some functionality down to the Uber client as an example. But the point here is that, you know, the threat model of defamation, of trying to affect availability is definitely an option. So I just go through some threat assertions. When you're doing threat modeling and you're in the threat motive designation, where you're trying to define what threats are going to have underlying attack patterns, this is stuff that's really important to do. Now, we talked about, in terms of a threat is just idle. until there's a viable attack pattern. If you're doing true threat modeling, you have to marry an attack pattern to each and every threat. And you might have 10 threats or 5 threats, and that's why it's important to do some things like attack trees. But from attacks can't really happen if you're not really targeting a weakness. So for example, I'm 6 foot tall. If I think that I can run straight through this wall, I'm foolish. There's no weakness in the structural of that wall, assuming that's concrete or something. So as an attacker, as a criminal, you want to be able to identify what weaknesses in process and technical vulnerabilities. And so with containers, there's a lot of them that have happened. Remote code execution or denial of service, Elasticsearch related vulnerabilities where there's also remote code execution. These are all been in containerized environments. And there's actually already payloads and Metasploit that have been checked into GitHub for these types of CVEs. Here's an example of an attack tree where basically, we look at a threat motive, and sorry you guys can't see this, and I can't even see it on here. But there's a threat, you basically want to organize your attack trees. If you're now thinking as a white hat, and let's say you are adopting containerization in your environment, begin with something like this, where you have different silos of threat motive, threat, asset, target, or component, your weakness, your attack vector, and vulnerability. And don't just look at the application layer of an attack, also look at other types of attacks that have precedence. The tainted images that I spoke of have happened, and people have adopted them into their DevOps. And they have had known vulnerabilities which they could be exploited remotely. But here you have the threat motive of, consumer confidence. Let's talk about, Uber. So I want to create service downtime. If Uber is down, as a consumer, I take a lot of Uber in different cities. If I'm waiting and waiting and waiting, I'm like, screw Uber. I want to take Lyft. It's that simple. That's how the customer loyalty is. It's that real. So if you can affect availability of a service of a competitor, this threat motive is totally viable. So you have the actual asset or target in this case is like, well, I want to target the Docker engine, and I want to basically rely on the fact that there's bad container management, by this organization, let's say Uber. And so I have 2 choices here as possible attack vectors. I can basically, rely on an untrusted container app that I have maybe as a, part of a multi-tenant. And with Uber, it's not going to make sense because I can't really reside in their environment. But for other things like Office 365 or Google-related business-to-consumer services, I could, use their SaaS offerings and be a tenant in their environment, or better said, with AWS. With AWS or any sort of cloud hosting model where they're doing, there's a hosting provider in the United States that has multi-tenant hosting, and if you want to you do it like a side channel attack right here, or you're basically an untrusted container application, seeing if you can be able to interface with the legitimate other containers in a multi-tenant environment. Now, if that happens, then what is the vulnerability that you're relying on is poor container isolation and privilege model. Now, granted, this is a black box effort. You don't really know how their isolation is unless you basically get intel from, different manifests or their Docker files, and you can kind of derive what their, isolation practices might be. But even easier might be just simply to interface with their highly advertised DevOps engineers on the internet and ask them what is their form of isolation and what isolation best practices they recommend. That's really the easiest way to go as a criminal, so that you can basically see if you can do a container breakout. Here's a Kubernetes example. I want to get to because I only have a couple minutes left, I want to get to the countermeasures. We've talked about some of the attack patterns of container breakout through poor DevOps management and isolation. But I want to talk about what some countermeasures you can do if you're basically in the business of securing containerized environments. By the way, this is something that I did, just really easy. Uber, Docker, see who's working, what is some dirt that you can target in terms of DevOps people. There's a guy named Zach. Got the picture, did a Google Goggles reverse lookup, and saw their social footprint on multiple different social avenues. And a lot of times people, they just don't change their pics. So you quickly profile who's who, and then you can interface with them as part of your attack model. And you're basically trying as an attacker to supplement your technical related attacks by basically, some technical related attacks might be fuzzing, Docker related web APIs. That's just purely technical if they're exposed. Another one might be, again, the side channel attack. But non-technical ones would be trying to get you get some information or intel from DevOps engineers by simply doing normal OSINT stuff. So in summary, the container attack library that everyone needs an attack library when you're doing threat modeling. So a good container attack library can be dishing man in the middle for default HTTP API access to Docker daemon sockets, forging certs for certificate authorities for secure connections, some side channel attacks, REST API command injection, kernel side exploits, which there's been a lot of. But here's some countermeasures that you can take home to the family. So basically, you have some configurations in terms of greater user confinement and user privilege models that are restrictive. You can also use tools like GRSEC and PAX in order to prevent kernel hacking or kernel tampering. So making sure that you're protecting the kernel so that it doesn't interoperate with other types of arbitrary command injection on the Docker container itself. GRSEC provides greater isolation for your container environment above and beyond what you can normally do with using IP tables at the kernel level or configuration of your CNAMEs at the Linux container level. But these are some mitigation strategies you have. There's tons of different tools. Most importantly, if you're going to adopt images, make sure that you get them from a legitimate repo. If you have any questions, this is contact information. I'm also at tonyuv@owasp.org. I'm out of time right now, but this is kind of a lot of content and more. And if you have some interesting attack ideas on containers and microservices, I'd love to hear about them, but I'll entertain any questions that you might have at this time. Yeah. You mean from Jesse? Sorry? You mean from Jesse? The image Jesse is doing a upgrade? So that goes with untrusted builds. I think it was that context. The reason why we're not doing an apt-get upgrade is because it depends on how you've configured your sources. It's better to basically get validated sources because that's definitely an attack vector, right? If you're doing package management through apt-get upgrade and it's going to the internet and your sources that you're relying on is basically part of your Jesse image in Debian, then you're at the mercy of good quality sources that have been vetted. But if you're just going to download it from the internet, just like any IT ops model, you should basically have first validate your sources and your mirrors that you're going to, get them to a central location, and then do all of your apt-gets locally within your on-prem environment. Yeah. So the question was, what do you think of Docker's, basically image trusts that they're trying to implement now, and also the different policies to secure, the Docker containers, and then also, what do you think about the security scanning that's going on from Docker today? And I think that's definitely a step in the right direction in both cases. I think that it helps mitigate some of the attack patterns that I mentioned here. But so it's definitely a huge step up. But I wouldn't trust the dynamic automated scanning, just like I wouldn't trust automated scanners in traditional web application security testing, because they're just going to catch maybe 30% of things.
Okay, I think we need to close now. Don't need Thank you very much.
Thank you.